Alright, sixth period. How we doing, guys? Hope everything is well. Happy Friday. Reminder, tomorrow I have Saturday school. I'm going to try to make this video short. Although it's a heavy topic, it's something that I'm going to make sure I go slow. Luckily for you, I'm making a video, so for those who need to see it a second or third time, they can always go back to the video. And when I return, if we need to go over it again, practice more with this skill, then we will definitely take some time to make sure we are able to master it. Here we go. Take out the Unit 4 polynomial and polynomial functions, please. We're still on review A. My expectation was for you to finish review B, 1 through 6, and 10 through 12. Today I'm going to be doing questions 7, 8, and 9 on review A using what is called long division. And you will be finishing 7, 8, and 9 on review B. Not only are you going to have these problems, but you also have a handout you're going to be receiving from the sub today, similar to the one for synthetic division. Okay, it's about 8 to 9 questions. I'm going to give you the answers, of course, but I'll go over some of these examples as well on the handout. Let's go ahead and look at the notes on page 10. If you go to where it's numbered 6, long division and or synthetic division, here's an example of step-by-step of long division. Now you should see this as a little familiar to something that you learned when you were in middle school, maybe even grade school, on how to divide. So it's kind of remembering those steps. And again, I'm going to make sure I take this approach very slow because I know it's a difficult skill for a lot of students in Algebra 2. Here we go. Actually, before I go over a polynomial divided by a binomial, I'm going to use this backspace here. All this white space, I'm going to use it to kind of remind ourselves of how to divide. Here we go. Let us recall if we have something like 125 divided by 5. If you don't know your division right away, you would use what is called long division, where you put your denominator here and you put your numerator inside of this little house looking thing. Alright, so now we're going to divide 125 by 5. And here's the kind of mindset you want to get yourself doing. So the first thing you got to do is check the first digit. Okay, here's the first digit. And you ask yourselves, can my 5 divide into 1? Okay, 5 does not go into 1 nicely. So what we're going to do is ignore the 1 by itself, and we're going to actually now look at two different things. We're going to be looking at the two first digits, 12. And we're going to ask ourselves, how many times does 5 go into 12? Basically, what multiplies 5 to get 12, or at least close to 12. And if you know your multiplication table, 5 times 1 is 5. 5 times 2 is 10. And if I go again, I'm going to go over the amount, 15. I can't use 15, so we're going to use 10. So that's what we're going to put right below the 12. Now the number that I just multiplied 5 to get 10 is 2, so I'm going to put the 2 on top. And again, I did 5 times 2 is 10. Okay, and then you have to remember you're going to subtract these values. 12 minus 10 would give us a result of 2. and then you carry down the last digit that we did not use to 5. And we repeat the process again. Ask ourselves, how many times is 5? Go into 25. Well, luckily for us, we already started our multiplication table here out to the side. 5 times 4 would be 20, and 5 times 5 would be 25. Ta-da, we can make it. So we're going to go ahead and multiply by 5. And we get 25. Subtract. So we can, again, I'm going to tell you that I multiplied 5 times 5 to get the 25 here. And what we end up getting is a remainder of 0. Remainder. Ran out of space there, sorry. So if there's a remainder of 0, what that tells you is that 5 is a factor of 125. That 5 divides 125. Okay, so I'm going to go ahead and show you now an example where we don't get a nice remainder of 0. And just to speed this up a little bit, here we go. I'm going to go ahead and use the same number 5, but now I'm going to do, let's do 123. So we're going to do 123 divided by 5. Let's use long division. 123. Here we go. Alright. So we take that same approach. Kind of already started off this piece here. We know that 5 does not go into 1, but 5 does go into 12 2 times. So I put 2. 5 times 2 would give us a value of 10. Okay, we're going to go ahead and subtract these. This would result in 2, carry down the 3, and now we know to find another factor or multiple of 5 that gives us close to 23. 5 times 5 gave us 25, so I can't go over, so I have to go back down to 1 digit more, so it'd be 4. So this would be 4 times 5 gives us not 23, but it would give us, in this case, 20. Okay, now we're going to go ahead and subtract, and what ends up happening here is that we have a remainder of 3. Now typically there's two different ways. We can stop here and keep the remainder of 3, or what we can do is find a decimal form of this, but for this one I want to make sure you see how it's connected to the long division we're going to be doing today. So this 3 is the remainder, so remainder of 3 over whatever we divided by. In this case we divided by 5, so we're going to put that in our denominator of this number 3, so it'd be 5 here. Oops, I'm not going to write with that. Here we go. So your answer would be 24, 3 over 5. Alright, so here we go. Moving on. First 3 examples, use long division. Alright, bear with me. If you're going to write this, make sure you're writing really, really small, because this page is not big enough. If you need scratch paper, do it on scratch paper. You know where to get some. Alright, let's go ahead and go. Here we go. We're about to divide this polynomial x squared minus x minus 56 by this x plus 7. Now, it's not the same approach as synthetic division. We don't have to solve our little binomial and set it equal to 0. We're going to keep it. So we're going to go ahead and set up the long division. Okay, here we go. So now that I have my problem set up, I'm going to go ahead and focus. Again, scratch paper or write really small and clear. If you're a sloppy writer, make sure you write your signs and numbers clearly so you don't mess up anything. Here we go. Alright, so what we're trying to do is focus on the first term. Our first term is x squared. And I only want to look at this x. I want to ask myself, how do I make x into x squared? What can I multiply by? I'm going to do this to the side in a different color. Well, if you recall, we know that x times x is x squared. So we've already created what we want. We want to make this to make sure it matches that. Since we know we're going to multiply by x, okay, we're going to go ahead and put that value in the first place, x. Now this is where you have to be careful and you take your time in doing this if you're not a speed stir in this part. We're going to multiply these two things. We're going to multiply x times x plus 7. I'm going to do this to the side. There we go. Depending again on your skills, you're probably going to have to do it on the side, or if you're quick with it, you won't have to. So we're going to have x times x plus 7. We distribute. This will result in x squared plus 7x. This is going to be brought there. So we're going to write x squared plus 7x. And don't forget we have to subtract. Now here is where common mistakes. Students can do this piece, but now we have to remember, since we're subtracting and we have two terms, we're going to have to include some parentheses on this little binomial we have here. Okay. Now two different approaches we can do. Again, we can distribute this negative, or we can take our time and just remember that we're subtracting. So I'm going to go ahead and highlight this. We're going to subtract. And I'm going to read it. I'll highlight it for you so you can see what I'm reading. Those are a little more visual. X squared minus x squared results in 0. So that was the goal, it was to cancel these, so this works out. So we're going to go ahead and cross these out. And let's continue. Now we're going to do negative x minus 7x. Negative 1 minus 7 would result in negative 8x. Now, if you need to pause the video at this time for those students that maybe need to check in with the neighbor to see how we got negative 8x, please take the time. If you're having a hard time understanding where we got this negative 8x, just copy it down. Again, make sure when I get back, we make sure to go over these skills and practice a little bit more. Here we go. Let's continue. So the next step is to bring down the last number we have, which was a 56. So we're going to bring it down. And I have to make sure you be, again, mindful, careful. It's a negative 56, so let's go ahead and bring down the minus 56. And now what we're trying to focus on is this negative 8x. And what I want to do is make this x into a negative 8x. Well, how am I going to do that? I'm going to erase this off to the side. Okay. Well, we should be thinking of, well, what's negative 8 times x? That's negative 8x. So what I need to multiply my x value with is a negative 8. So I'm going to bring over the negative 8, put them on top. Negative 8 or minus 8, however you want to say it. And now let's go ahead and multiply this negative 8 to this binomial x plus 7. So we're going to have negative 8 parentheses x plus 7. we're distributing here. Negative 8 times x is negative 8x, and then negative 8 times a positive 7 is a negative 56. We're going to go ahead and write this over here under our division problem here. And again, now we have to remember to put some parentheses on this result and a minus sign. There we go. Once again, you have to be mindful, careful with this negative, and these will change into pluses if we distribute the negative. So for this piece, I will do just that. Let's do it in a different color here for you guys. Let's do distributive and negative. We'll change these into pluses. And now let's go ahead and combine. If we combine correctly, we have now a negative 8x and a positive 8x. They're opposites, so they're going to cancel out. So I'm going to go ahead and cross them out to make 0. And same thing is going to happen if you focus on the negative 56 plus 56. Negative 56 plus 56 is 0. So we're going to go ahead and cancel those out. And we end up with a 0 remainder. So we know that this x minus 8 is a factor of the original polynomial that we just divided, x squared minus x minus 56. Once again, remind, excuse me. If I were to multiply the binomial x plus 7 and x minus 8, my result would be x squared minus x minus 56. So that's the long division skill that we need to continue to practice. And again, this is a pretty difficult topic for most students, is what I hear from the other Algebra 2 teachers. So again, I'm trying to take a very slow approach. Luckily for you, again, the video is going to remain here. It's going to be posted on Google Classroom for you guys to always go back and reference if you need that. Here we go. Alright, so now let's do number 8, second example. We have 2x squared minus 5x plus 6 divided by x minus 1. We're going to use long division. Some of you are probably thinking, well, can I just factor? Yes, of course. But then we're going to get to polynomials that are bigger than power of 2 or require a little bit more skill for you to factor. So let's just practice the skill of long division first, okay? So we're going to have x. Oh, let's use a different color. Don't like yellow for this right now. Alright, let's go. Alright, so we're going to have x minus 1, 2x squared minus 5x plus 6. And again, step by step, I'm going to take this x and try to make just that x into a 2x squared. So what I need to be thinking of is, how do I make an x into 2x squared? So let's go ahead and think opposite side, different color. Well, I know I have to multiply by 2 times x. That's going to give me 2x, but I want to make it to the power of 2, so I would have to multiply by another x. So 2 times x would result in 2x squared. Now I don't need 2 x's, I just have, that's that one there. So I need to multiply by 2x, so that's what I'm going to put right above my numerator. Okay. And then with this 2x, I'm going to go ahead and distribute it to the x minus 1. Here we go. So we're going to have 2x, parentheses x minus 1, distribute. 2x times x is 2x squared. 2x times a negative 1 is negative 2x. And now I'm going to go ahead and write this right below the 2x squared minus 5. Once again, I will remind you, put your parentheses, put a minus sign, and you have two options. You can either distribute the negative to switch the signs, or you can just remember that you're subtracting, so you take your time doing that. So first thing we're going to do, let's go ahead and combine these. We have 2x squared minus 2x squared. That's going to result in 0, so we're going to cancel these out. So cross out. Next thing I need to combine, the next two terms, is going to be negative 5x minus a negative 2x. So that's going to turn it into a negative 5 plus 2. Negative 5 plus 2 would be negative 3. And since there are x's, let's bring down the x. Carry down your 6, so it's a positive 6. And now we repeat the process again. Here we go. I now need to make this x into a negative 3x. So I don't have to multiply by x because it's already the same degree. All I have to do is multiply my x with a negative 3. Again, if you need to see that, here we go to the side. Negative 3 times x is negative 3x, which would, again, make that same number there. All right, let's write negative 3. And now I'm going to go ahead and take that negative 3 and distribute it to an x minus 1 to see the result of it. To the side work. Negative 3, x minus 1. Let's distribute. Negative 3 times x is negative 3x. Negative 3 times negative 1 would be positive 3. I'm going to go ahead and write this down here. All right, let's go ahead and add our parentheses and our minus sign. Let me zoom out a little bit. Let's move the page. Here we go. Negative 3x minus a negative 3x. The minus minus at the bottom will turn into a plus. That's negative 3x plus 3x would be 0. Those cancel out. And now we're going to see that we don't get a remainder of 0. Positive 6 minus positive 3 would result in 3. And we find a remainder of 3 at the end. So this again would be equal to 3. Again, it's a subtracting sign. Don't think that we're adding here. Don't forget this, again, minus sign. I'm going to highlight that so we don't forget that. Here we go. So that remained a value of 3. This is a remainder. And let's go ahead and remind ourselves. How do we write the remainder at the end? Well, let's go back to the example I showed you. When you have a remainder, you take the remainder. This case was 3. And we take what we divided by, our denominator, and we put it under that remainder. So let's do the same thing here. So it'd be 3 Since it's positive 3, we're going to have to put a plus here. And then we're going to put it over our divisor, which was x minus 1. Let's go ahead and clean this up by writing it nice and clear off to the side. Again, what this is telling us is that x minus 1 is not a factor of the polynomial that we just divided. Here we go. Let's do this in green. So the final answer after you divide, your result would be the following. All right, here we go. Example number 9. Okay, example number 9. We look at the polynomial. It is now a polynomial of degree 3. So what I want to make sure is I don't have any missing degrees. It goes 3, 2, 1, and then constant. So this is all good. We have everything we need. There's no zeros that we have to put in. What I do want to do, though, is rearrange 1 plus x into standard form. Standard form is when you have the variable with the highest degree in the front, and then the constant goes at the end. So let's go ahead and do that. This is going to turn into x plus 1. Okay, so let's go ahead and do this once again. Let's write down the problem first before I get too ahead of myself. We have x plus 1, and we're dividing this big polynomial. Let me erase this. Don't need it now. And okay, let us begin. So what we want to do is, again, remember what we have. We're going to look at our first term, x to the power of 3, and I need to make my x into x to the power of 3. Well, how do I make x into x to the power of 3? I would multiply x to the power of 2 times my x that I have here, and x squared times x is x to the power of 3. So this is what I have to put on top. Let's erase this here. And now we're going to go ahead and distribute my x squared into x plus 1. This is side work here. So x squared, parentheses x plus 1, distribute x squared times x is x to the power of 3. X squared times a positive 1 is still a positive x squared. So we're going to go ahead and write that down here. X cubed plus x squared. And we have to remember, again, the little rules that go along with long division. We're going to subtract, but we can't forget our parentheses. And now it's going to be mindful. X cubed minus x cubed is going to be 0, just like we wanted. They will cancel out. And now let's do the next piece. Positive 5x squared minus positive x squared is just going to be a 4x squared. And now we're going to carry down my next term, which is a positive 7x. And now we're going to repeat the same process step by step. Here we go. So I need to make my x into a 4x squared. I know x times x is x to the power of 2, so that's going to give me the x to the power of 2. And I need to multiply by 4 to make it 4x squared. Let me show you again what I mean up to the side. 4x times x, remember this x is the same as that x there. And if you multiply this, you get 4x to the power of 2, which matches what we're trying to make right there. So let's go ahead and multiply by 4x. Since it's positive 4x, you're going to put plus. Plus 4x. Now let's do this math to the side. We're going to take our 4x and multiply by x plus 1. Alright, so let's go ahead and do that. 4x times x is 4x to the power of 2. 4x times a positive 1 is positive 4x. I'm going to go ahead and write that down over here. Zoom in. So we got 4x squared plus 4x. Remind ourselves to put our parentheses and our minus sign. Take your time. 4x squared minus 4x squared is 0, just like we like to see. Cancel out. And now we do the next piece. 7x minus 4x. That's just 7 minus 4, which is 3x. So we get 3x. I'm going to carry down my last term, which is a positive 3. Okay. Now let's look at this. Problem's getting pretty long, but here we go. We got this. Alright, so now I need to make my x into a 3x. Well, easily, again, hopefully it's easy to remember that 3 times x is 3x. So I need to multiply my x by 3. So it is a positive 3, so we're going to put plus 3. And now we're going to take, again, this value of positive 3 and distribute it to the x plus 1. So we get 3 parentheses x plus 1. Distribute, we get 3x plus 3. And we're going to go ahead and write that down below here. Some of you can already kind of foresee that it's about to give you a remainder of 0. Don't need to rush it though, take your time. Subtract with parentheses, and we're going to do it again slow. 3x minus 3x is 0. Cancel out. And again, 3 minus 3 is 0. So we can go ahead and cancel those out. We get a remainder of 0. Remainder. And again, let's remind ourselves what this tells us. It tells us that x plus 1 is a factor of this big polynomial, excuse me. This also tells us that x squared plus 4x, let's do that in a different color, Tells us that x squared plus 4x times x plus 1 would give us a result of x to the power of 3 plus 5x squared plus 7x plus 3. Okay? So let's write our answer here. Let's write our final answer somewhere off to the side. It'd be x squared plus 4x plus 3. Okay, you do have a shorter period today. Expectation is for you to finish. Don't worry about the backside right now of polynomials A, modeling polynomials A. You're going to do 7, 8, and 9 using long division. Those are very similar to the ones we did. But I want you to have more practice because, again, this is something that requires you to repeat some skills. Repetition is always key. Now, there's no point of you getting frustrated when you don't understand it, when you don't try this at home. So please try these at home. Here's the homework. Now, I want to cut this video short. What I'm going to do is make a second video shorter than this video that you're seeing here in the classroom, going over some of these questions here on your homework. So I'll give you some additional ones that you can use as examples and copy down. That's only because some of these require you to fill in some zeros because some terms are missing. For instance, on number 5, x to the power of 3, there is no x to the power of 2, there is no x, so then we would fill in some zeros, and I'll show you how to do that and how to go about that. Here, let's go ahead and give you the answers for these. So I'm going to scroll down. Here's the key. The answer for 1 on the long division polynomials is m, 2d, 3 is exclamation mark, 4n, 5r, 6i, 7s, 8a, 9e. Okay. I'm here for tutoring, or not for tutoring, excuse me, for Saturday school. I guess that counts as tutoring as well. If you want to come in and practice some of this, or again, you want to make up some quizzes, make up some tests, retake a test, retake a quiz. Hope to see some of you there. We'll also be at today's game, homecoming game. So hope to see some of you there. Okay. Have a nice day. Goodbye.